Imagine you were handed a map of the Earth, but the continents just don't look quite right.
Right.
And the oceans, well, they're nearly gone.
Completely vanished in some places, yeah.
Exactly. And the scale of this map is just completely alien. I mean, this isn't a map from the last ice age or, a speculative drawing of Pangaea.
No, not at all.
It's a map from roughly 1.2 million years ago. And on this specific map, the Earth's diameter is a massive 20,800 kilometers.
Which is just staggering when you really think about it.
It really is.
Mm-hmm.
So just to put that into perspective for you listening, our current planet is about 12,742 kilometers across.
Give or take, yeah.
Right. So because the planet was so much larger back then, the total volume of water we have today was stretched like incredibly thin across this vastly expanded surface area.
The water doesn't change, just the container.
Exactly. So the oceans were nearly 5,000 meters lower than they are right now. If you were to look at this map, today's deep abyssal ocean plains, the dark, crushing depths where we send those robotic submersibles, they are vast, dry, scorching deserts.
Yeah, completely exposed to the open air.
And those deep sea mid-ocean ridges, they are towering mountain ranges, like piercing the sky.
It is an absolute radical inversion of the world as we know it. I mean, we are so accustomed to looking at a globe where the color blue dominates over, 70% of the surface?
Yeah, something like that.
But on this specific geological model, the blue is relegated to these narrow, ultra-deep trenches.
It sounds like a sci-fi movie.
It really does. It feels like a completely different planet, yet it is the exact ground we are standing on today, just viewed through the lens of deep time.
Okay, let's unpack this, because here is where it gets really, really interesting.
Let's do it.
We aren't just sitting here discussing, niche geological models for the fun of it. We are looking at a stack of sources today that reveal this staggering, almost impossible alignment between modern paleontology, deep-sea tectonic science, and, of all things, ancient Sanskrit epic literature.
Specifically the Ramayana.
Yes, specifically we are diving into the Kishkindha, which is a really critical chapter of the Valmiki Ramayana.
Right.
So our mission today for this deep dive is to track the exact step-by-step westward route that the Vanara king, Sugriva, commanded his army of 200,000 soldiers to take.
This was when they were sent to search for the kidnapped princess, Sita.
Exactly. We are essentially going to use a mythological poem, one that was passed down through oral tradition, as a literal high-fidelity GPS navigation system for a prehistoric expanded Earth.
Which is a brilliant and, frankly, highly controversial premise for an analysis.
Oh, absolutely.
The text places these events in what Hindu cosmology calls the Treta Yuga, which temporally corresponds to approximately 1.2 to 1.7 million years ago. Right. So to genuinely grasp the implications of what we are talking about here, we have to forcefully strip away modern geography, completely ignore the map,
Throw it out the window.
Exactly. We have to look at the Earth through the mechanics of continental drift, marine regressions, which is just when sea levels drop drastically, and this expanded globe model.
Okay, but wait. I have to pause you right at the starting line here.
Sure.
Because I know the person listening to this is probably thinking the exact same thing I am right now.
Which is?
An Earth that is 20,800 kilometers across. That fundamentally breaks the laws of physics as I understand them.
Ah, right. Gravity.
Yes. If you nearly double the size of the Earth, doesn't the mass increase? And wouldn't the gravity increase exponentially to the point where, a 200,000-strong army of primates couldn't even stand up, let alone march across continents?
It's a great point. But if we connect this to the bigger picture of the expanding Earth hypothesis, the mechanics actually solve that exact problem.
Wait, really? How?
Well, the theory postulates that the Earth's mass remained relatively constant.
Okay, but its volume expanded. This could be driven by thermal expansion, changes in the core, or maybe decompression of deep mantle materials over millions of years.
So the same amount of stuff just taking up more space?
Precisely. If the mass is constant, but the volume is significantly larger, the overall density of the planet is actually lower.
Oh, I see.
And because the surface is now physically further from the center of mass, the surface gravity would have been noticeably lower than it is today.
Okay, so things could actually grow larger.
Exactly.
Yeah.
A lower surface gravity perfectly accounts for the megafauna we see in the paleontological record of those eras.
Right. The giant sloths, And massive dinosaurs.
Yeah, massive dinosaurs, giant mammals, enormous insects that simply couldn't exist biomechanically under our current gravity. They would just collapse under their own weight today.
That makes total sense.
And interestingly, it lends a physical framework to the descriptions in the Ramayana of the Vanars themselves.
Because they're described as being huge, right? Yeah, they are described as possessing immense towering statures and leaping these incredible distances. Under a lower gravitational constant, those physical feats transition from mythology into actual biomechanical possibility.
That completely reframes how I'm visualizing this whole thing. So we have an expanded planet, lower gravity, and oceans that are practically empty compared to today.
That's the stage.
I really want you to hold on to that image as you listen. And just consider how much of what we casually dismiss as mythology might actually be tightly encoded geological memory.
It's a profound thought.
Really is. But to trace a journey of this magnitude across vanished oceans, we need a starting point. And according to our source material, the traditional starting point is completely wrong.
Yes. This is where applying geological science to ancient texts gives us our first major pivot.
Right.
Traditionally, if you look at modern religious geography, Kishkindha, which was the capital of the Vanara kingdom, is believed to be located in modern-day Hampi.
Which is down in the southern Indian state of Karnataka.
Exactly. It has the beautiful temple ruins, it has the local folklore. Everyone assumes that's the spot. However, according to the tectonic contraction model we are examining today, the original Kishkindha wasn't in modern Hampi at all.
Not even close, right?
Right. Millions of years ago, it was situated exactly on the Tropic of Cancer,
Okay.
specifically at the intersection of the Malwa Plateau and the Aravalli Range.
So for anyone looking at a modern map, where is that exactly?
This is the border region of Madhya Pradesh and Rajasthan, right around the ancient city of Ujjain.
Got it.
We are talking about precise coordinates here,
Right.
roughly 23.5 degrees north latitude and 75.5 degrees east longitude.
But, I mean, why throw out centuries of tradition? Hampi has been the accepted location for generations. Why shift the starting point hundreds of miles north just to fit some tectonic model?
Because if you don't do that, the ancient text itself breaks down completely.
What do you mean?
Well, the Valmiki Ramayana provides a highly specific global compass when Sugriva is giving directions to his armies. He references cardinal directions relative to specific, immovable mountain ranges and river systems.
He's giving them landmarks.
Yes. And if you place Kishkindha in Hampi, the geographic directions Sugriva gives are nonsensical. They simply do not align with the described landmarks.
That's interesting.
But if you place the capital at 23.5 degrees north, right on the Tropic of Cancer near Ujjain, the text's compass works perfectly.
Well, it lines up.
Flawlessly. From that exact coordinate, the massive Vindhya mountain range is to the exact south.
Right.
The Ganga and Yamuna river basin is to the exact east. It is literally the only geographical coordinate on the entire Indian subcontinent where Sugriva's orientation matrix is mathematically accurate.
Wow. So if the capital was originally way up near Ujjain, what forced the entire civilization to move south to Hampi? Was it just a change in leadership, or did the Earth itself force them out?
It was forced by massive climatic and geological shift.
Like climate change.
Extreme climate change. As the Earth transitioned between eras, what the Sanskrit texts refer to as the changing yugas, the planet underwent tectonic shrinking and intense climatic alteration.
Okay.
The once lush, vibrant region around the Malwa Plateau and the Aravalli Range suffered severe aridification. It basically turned into a harsh desert environment.
So they couldn't survive there anymore.
Exactly. This slow-moving environmental catastrophe forced the civilization to migrate south over millennia. They eventually established a new Kishkindha in the much more hospitable region of modern Karnataka.
Just like people naming New York after York. It's a transplanted city name.
That's a perfect way to look at it. But the original starting point for this specific search, the epicenter of the journey 1.2 million years ago, was firmly planted on that 23.5-degree north parallel.
Okay, so picture this. The army of 200,000 soldiers is mobilized near modern-day Ujjain.
Yep.
Sugriva points them directly west, telling them to follow that exact 23 to 24-degree north parallel. And according to the text, the first major landmark they will hit is Somagiri.
Right.
It's described as this colossal mountain located at the place where the Sindhu, which is the Indus River, meets the ocean.
Which presents our first major geological anomaly.
Why is that?
Because millions of years ago, the Proto-Indus River did not flow through the fertile plains of Punjab and Sindh like it does today.
Wait, rivers move. I mean, I always thought of major rivers like the Indus or the Nile as permanent geographic fixtures.
Oh, they are anything but permanent on a geological timescale.
Really?
Yeah. Modern geological and paleontological research, heavily reliant on deep sediment drilling and isotope analysis in the Arabian Sea, shows us exactly where the river's ancient mouth used to be.
And it wasn't where it is now.
Not at all. During the Eocene to Oligocene periods, the early Indus River flowed much further west. It carved its path straight through Balochistan's Katawaz Basin and the Makran Marine Trench.
Okay, so where did it hit the ocean?
It emptied into the ocean near the modern border of Iran and Pakistan.
Wow. So what forces a massive river system to just pack up and move hundreds of miles to the east?
The relentless movement of the Earth's crust.
Tectonics.
Exactly. As the Indian tectonic plate rapidly pushed north and violently collided with the Eurasian plate, which, by the way, is the exact same collision that is still pushing the Himalayas higher today, it caused massive tectonic uplift along its western edge.
Okay, so it's not like a boulder blocking a stream. It's more like a tectonic bulldozer, just shoving the actual crust of the Earth upward, tilting the entire landscape.
That is a perfect analogy. The uplift literally pushed up the Suleiman and Kurthar mountain ranges in Balochistan.
Wow.
As the land tilted, it created an impenetrable dam. The Proto-Indus River was totally blocked from its western route.
And water always finds the lowest point.
Exactly. Gravity forced the water to migrate east-southeast, eventually settling into the foreland basin of modern Punjab and Sindh.
But at the time of the Ramayana,
At the exact time of our journey, the text accurately places the mouth of the river far to the west, exactly where modern sediment cores prove it used to be.
that is incredible. And at the mouth of that ancient vanished river, the text says the army encounters Somagiri.
Right.
It's described as a towering mountain with 100 peaks. But, I mean, when I look at a topographical map of the Makran coast today, there is no towering mountain there. It's just flat water. It's the Arabian Sea.
Well, that is true if you only look at the surface.
Okay.
But if you look at a bathymetric map, which is a map of the ocean floor right off the coast of the Makran Trench, you find the Murray Ridge and the Makran submerged ridges.
Submerged being the key word.
Right. Today, this is a massive submarine mountain chain stretching over 750 kilometers. The highest peaks of the Murray Ridge, specifically an area known as the Dalrymple Topographic High, are currently 300 to 800 meters underwater.
But we aren't looking at today's map. We're looking at a world where the sea level is 5,000 meters lower because the ocean basins are stretched out.
Precisely. So if you remove 5,000 meters of water, the entire Arabian Sea basin empties out.
It's just gone.
It ceases to be an ocean entirely and becomes a vast, deep continental valley. And that underwater Murray Ridge, it is suddenly fully exposed to the open air.
Oh, wow.
The Dalrymple Trough area would tower 4,500 to 4,700 meters above the newly exposed valley floor.
To put that in perspective, that is comparable to standing at the base of the Alps or the Rocky Mountains and looking straight up. It would be an absolutely staggering wall of rock.
And the physical scale is breathtaking. Because it's a jagged tectonic ridge, it wouldn't just be one solitary peak, like a volcano.
Right.
The entire system would present as a massive, continuous mountain range featuring 40 to 50 distinct, towering peaks. It perfectly matches the Ramayana's description of a singular, massive mountain system crowned with 100 peaks.
Okay, so the geography tracks perfectly.
Yeah.
But the text doesn't just describe the mountain, right? It describes what lives on it.
Ah, yes. The fauna.
Yeah. Sugriva warns his army that Somagiri is home to lion birds.
Yes.
Apex avian predators so massive and powerful that they can literally swoop down and carry whales and elephants into their nests on the high peaks.
Right.
And I'll be honest, when I read that in the source material, I almost laughed.
It sounds absurd at first.
It really does, carrying whales. It sounds like we stepped out of a geology textbook and straight into a high fantasy novel.
It does raise a very important question about how we filter ancient texts through our modern biases.
How do you mean?
Well, it is extremely easy to dismiss a detail like that as pure mythology or poetic exaggeration. But let's connect this back to the physics of the expanded Earth we just discussed and the cultural memory of the broader region.
Okay.
Across ancient Middle Eastern and Mesopotamian art, From Egyptian sphinxes to Persian bas-reliefs, you constantly see iconography of winged lions.
Right, like griffins.
Exactly, we usually call them griffins. What's absolutely crucial to note here is the specific terminology used in the Sanskrit text.
Yeah, the translator's notes specifically point out that the text does not call these creatures Garuda.
Exactly. In Hindu and Sanskrit literature, Garuda is a very specific, highly revered divine eagle. It's the celestial mount of the god Vishnu.
So it's a mythical figure.
Yes. If the author of the Ramayana merely wanted to invoke a mythical divine bird to sound impressive, they would have simply used the word Garuda.
But they didn't.
No, they didn't. They used descriptive language for a unique local species, a winged lion, an apex avian predator native to those specific mountains at that specific time.
And if we factor in the lower gravity we talked about earlier, I mean, a lower surface gravity would mean a denser atmosphere relative to the planet's pull.
Yes, the atmospheric mechanics change.
That makes flight much easier for larger mass creatures. We already know from the fossil record that birds like the Argentavis, which had a wingspan of over 20 feet, existed in South America.
Absolutely.
So if you have a completely different gravitational atmospheric environment, an enormous predatory bird capable of lifting heavy prey isn't a magical creature. It's just an extinct piece of megafauna.
Exactly. When Sugriva is briefing his generals, he isn't sitting around a campfire recounting a myth to entertain them.
He's giving them orders.
It's a tactical briefing. He is describing the local, highly dangerous fauna of a distant mountain range, so his troops know exactly what to look out for.
Okay, so this massive army navigates these towering, Alps-sized mountains that are today completely underwater, trying to avoid these massive aerial predators.
Right.
And once they cross the peaks of Somagiri, they push further west.
Right, following that 23-degree parallel.
Geographically, pushing west from the Arabian Sea brings us into North Africa. Specifically, they're moving into what we know today as the Sahara Desert.
Yes.
But stepping foot into the Sahara back then would have been a very different experience, wouldn't it?
It would have been totally unrecognizable. During the late Cretaceous, extending into the early Paleogene eras, northern and central Africa were not desert landscapes.
There weren't sand dunes.
Not at all. They were entirely submerged by what geologists call the Trans-Saharan Seaway, or the ancient Tethys Sea.
So it was underwater.
It was a massive, shallow inland sea that violently bifurcated the African continent. It stretched all the way from the modern Mediterranean Sea down to the Gulf of Guinea. The sweeping sand dunes and arid, rocky plateaus of the Sahara simply did not exist. It was a vast expanse of tropical salt water.
And we know this for a fact because of paleontology, right? It's not just a guess.
Oh, it's proven beyond any doubt. Paleontologists have spent decades digging in the most arid, punishing parts of the Sahara, places like Mali and Niger.
And what do they find?
They are constantly unearthing marine fossils. They find the remains of ancient sea turtles, massive extinct crocodiles, sea snakes, and shallow water sharks buried right in the middle of the desert sands.
That is just wild to think about. Shark teeth in the middle of the Sahara.
It really is.
And the Ramayana text tracks perfectly with this prehistoric reality. It describes the army moving west and coming across the Pariyatra mountain.
Right.
Sugriva describes it as a spectacular mountain with golden peaks rising right out of the middle of the sea, measuring 100 yojanas wide. He also mentions it's guarded by hundreds of millions of fiery Gandharvas, which are like these celestial warriors who glow like fire.
Yeah. So if you draw a straight line west along our 23 to 24 degree north parallel from the Arabian Sea, cutting right across that ancient Trans-Saharan Seaway, you hit the Hagar Mountains.
Okay, where is that today?
Specifically Mount Tahat, which is located in modern-day Algeria.
Got it.
Today, Mount Tahat is the highest peak in the Hagar Mountains, sitting in the middle of a very dry, rocky desert plateau. But back then, during the time of the Inland Seaway, the Hagar Shield was entirely surrounded by water.
Hold on, I want to clarify something for myself and the listener. The source material refers to the Hagar Shield as a, quote, Precambrian rock formation.
Yes.
What does that actually mean in terms of the landscape? Like, why does that matter?
The Precambrian era accounts for the vast majority of Earth's history, going back billions of years. When geologists refer to a Precambrian shield or a craton, they are talking about the ancient, original rocky core of a continent.
So it's the foundation?
Exactly. It is incredibly dense, crystalline rock, usually granites and gneisses, that is fundamentally stable. It doesn't fold or easily erode like softer sedimentary rock does.
So as the sea levels rose and flooded the softer, lower elevations of North Africa, This incredibly dense, massive dome of ancient rock just stood firm.
It didn't budge. It was a prominent, uplifted island massif. The Ramayan's description of a massive mountain, quote, in the middle of the sea, is a flawless one-to-one geological match for the Ahagar Shield during the Trans-Saharan Seaway period.
If you put yourself in the sandals of one of those soldiers, the psychological impact must have been staggering.
Oh, absolutely.
I mean, you have just walked across a dry ocean basin, you've climbed a jagged mountain range as tall as the Alps while dodging giant predators, and now you are standing on the shore of a massive inland sea in the center of Africa.
And the climate would be intense.
The heat would have been crazy, the humidity oppressive, and right in the middle of this vast water is a solitary, towering island fortress. It feels like a cinematic masterpiece, but it's grounded in absolute geological fact.
And the geological tracking gets even more specific and nuanced as they attempt to cross that sea. This brings us to the western shore, which presents a really fascinating geographical puzzle.
Oh, this is my favorite part.
It's a great puzzle, and one that I think actually proves the authenticity of the text's geographic knowledge more than anything else we've discussed so far.
Okay, let's trace this. The army moves past the Ahagar Island, and they need to reach the western shore of Africa.
Right. Geologically, across the water from the Ahagar Island was the ancient, rigid West African craton.
Another craton.
Yes. Like the Ahagar Shield, this is a very old, stable part of the continental lithosphere. And we have definitively mapped its ancient shoreline because marine fossils perfectly outline its eastern edge right through modern Mali and Mauritania.
Right. But here is where I hit a massive roadblock when I was reviewing the source data before the deep dive and comparing it to a modern map.
The sequencing.
Yes. The text lays out a very specific sequence of landmarks. It says that after dealing with the inland sea, the army visits Vajra Mountain, which is described as being blue and as hard as a diamond.
Right.
And then, after Vajra, they visit Chakravan Mountain, which is this massive circular mountain.
That's what the text says.
But if you actually look at the coordinates, and you are walking in a straight line west from the Ahagar Island, the geography is reversed.
Right. It seems backward.
Chakravan, which is at roughly 11.4 degrees west longitude, comes before Vajra, which is further west at 12.5 degrees.
If you're walking a straight line.
Exactly. So did the ancient writers make a mistake? It feels like they got their own map backward.
It absolutely looks like a sequencing error if you were only looking at a two-dimensional map and assuming they marched in a perfectly straight mathematical line.
Which an army wouldn't do.
Exactly. If
Yeah.
we connect this to the physical reality of moving a massive army, it reveals a brilliant boots-on-the-ground geographic logic. Remember, Ahagar was an island situated in a deep sea channel. The eastern coast of the West African craton was quite distant across open water.
So they couldn't just hop over.
Right. If you are commanding an army of 200,000 soldiers on foot, you don't suddenly halt your march to build a massive fleet of transport ships to cross a deep inland sea if there is an overland alternative.
You would just walk around the water?
Precisely. The most logical and efficient route for a massive land army was to bypass the deep sea channel by dipping south. They would follow the shallower waters or the southern land bridge around the basin and then hook back northwest to step onto the dry, stable ground of the craton in modern Mauritania.
So they took a detour.
By taking the southern detour to avoid drowning your army, you wouldn't be approaching these mountains from the east anymore. You would be approaching them from the south.
Oh.
And if you approach from the south, the army would naturally hit the Chakravan structure first and then proceed laterally to the Vajra Mountain.
That is incredible.
It's not a textual mistake. It's the exact physical route a tactical commander would take when navigating around a prehistoric sea.
It implies the text wasn't written by someone just looking at a star chart in a temple somewhere. It was informed by someone who actually had to walk the terrain.
Exactly. Boots on the ground.
So let's look at what they actually found when they stepped onto Mauritania, starting with Chakravan.
Okay.
The text describes Chakravan as a perfectly circular mountain built by Vishwakarma, who is essentially the architect of the gods.
Right.
It is the site where the Sahasrara Chakra, the spinning, disc-like weapon of Vishnu, was supposedly forged.
And when you look at that exact coordinate in Mauritania, 21 degrees 7 minutes north, 11 degrees 24 minutes west, you find the Richat structure. It's famously known around the world today as the Eye of the Sahara.
If anyone listening hasn't seen an aerial photo of the Eye of the Sahara, you need to pull out your phone and look it up immediately. It is one of the most bizarre geological formations on the planet.
It truly is a marvel. It is a perfectly symmetrical, massive, concentric ring structure stretching 40 to 50 kilometers wide.
It's huge.
Geologically, it's a deeply eroded alkaline volcanic dome. The rings themselves are made of highly weather-resistant quartzite.
So what does it look like if you're standing in it?
If you are just walking through it on the ground, it just feels like a series of circular rocky ridges.
Yeah.
But from an elevated vantage point, or viewed from space, it looks exactly like a giant deep blue and purple chakra, or a cosmic bullseye, carved directly into the Earth.
Oh, wow.
To an ancient observer, it is an absolutely flawless physical manifestation of a, quote, circular mountain where a giant chakra was forged.
The visual match is stunning. And then, just west of the Eye of the Sahara, they hit the next landmark. Vajra Mountain.
Yes, Vajra.
The description for this one is highly specific, too. The text says it is a mountain blue in color, like lapis lazuli. It says it is 100 yojanas wide, and it is as hard as a diamond. In fact, Vajra translates to diamond or a thunderbolt, implying ultimate hardness.
And right there, just west of the Richat structure, sits a massive peak called Kishkindha.
What's special about it?
This is not a normal mountain made of dirt, sandstone, or granite. It is what geologists call a banded iron formation, or a BIF.
I need you to explain that, because how does a mountain of pure iron even form? It sounds like something out of a sci-fi movie. Does liquid metal just bubble up from the Earth's core and harden?
Not exactly. It is actually a fascinating story tied to the Great Oxidation event billions of years ago.
Okay, take me back.
In the early oceans of the Earth, there was a massive amount of dissolved iron just floating in the water, but there was almost no oxygen in the atmosphere.
Right before plants.
Exactly. Then, early cyanobacteria evolved and started producing oxygen through photosynthesis.
And what happened when the oxygen hit the water?
When that free oxygen hit the ocean water, it reacted with the dissolved iron. Essentially, the entire ocean began to rust.
The whole ocean rusted.
Yeah. This heavy iron oxide precipitated and sank to the seafloor, layering over millions of years. Eventually, tectonic forces shoved these incredibly dense, thick layers of pure iron up to the surface, creating these massive formations.
That is wild.
So Kishkindha is a mountain made of almost pure magnetite and hematite. We are talking about a structure that is 65 to 70% pure iron.
So it's basically a gigantic metallic lasagna that got pushed out of the Earth.
That's a funny but accurate way to picture it.
Which means it actually is as hard as a diamond or a thunderbolt. Yeah. It's an impenetrable mountain of solid metal.
Exactly. Its extreme density makes it incredibly hard to mine or traverse. And because of that high concentration of high-quality hematite and magnetite, the rock isn't a dusty brown or gray like normal mountains.
What color is it?
When the sun hits it, it gives off a distinct metallic bluish-gray color. Even today, the local populations refer to it as the Blue Mountain. The Ramayana's description of a mountain blue as lapis lazuli and hard as Vajra isn't a metaphor. It is a perfectly literal, scientifically accurate description of the unique metallurgy of Kishkindha.
Okay, let's just take a breath and recap where we are for a second. We have tracked this army from central India, down a river that no longer exists, over mountains that are currently underwater, around a massive prehistoric sea in the middle of the Sahara, past a 50-kilometer-wide eye in the earth, to a mountain made of solid blue iron.
And they are still marching west.
Reaching the western edge of Africa, the army now faces the Atlantic Ocean.
But again, we must aggressively adjust our perspective back to the expanded Earth model of 1.2 million years ago.
Right, the 20,800-kilometer diameter planet.
The water is stretched thin, the sea level is 5,000 meters lower.
The Atlantic Ocean isn't a body of water that you can just build a fleet and sail across.
No, it is a vast, terrifying, immensely deep valley that must be traversed on foot.
So if I were standing on the coast of West Africa, looking down into that, what would I actually see?
Picture the Canary and Cape Verde abyssal plains, which today form the deep, dark ocean floor.
Okay.
If you remove 5 kilometers of water, it wouldn't just be a dry, sandy desert. The shallower parts of the continental shelf would be coated in massive, barren evaporate deposits.
Like salt flats.
Exactly. Infinite plains of blinding white salt stretching for thousands of kilometers, just crunching under the feet of the army.
And what's in the middle?
In the very center of this massive basin, in the deepest abyssal trenches where the crust pulls apart, there would be a narrow, ultra-deep residual sea.
And the atmospheric pressure down there must have been completely insane.
Oh, absolutely.
I mean, if you're 5,000 meters below what we consider sea level, The weight of the air on top of you would be crushing. It would be incredibly hot, dense, and suffocating.
It would be a total hothouse environment, unlike anything we experience today. It would create violent, deeply unstable weather patterns.
So they're walking down this steep continental shelf through the salt plains into the abyss. And the text says they reach Varaha Mountain, which translates to the Golden Boar.
Yes.
It's described as a spectacular mountain located in the fathomless ocean, featuring golden peaks and measuring 64 yojanas wide.
If we follow our strict 23-degree north parallel straight off the coast of Mauritania and West Africa, venturing out into the Atlantic basin, we hit a massive geological structure known as the Tropic Seamount.
And what does that look like?
Today, its highest peak is submerged at about 1,000 meters underwater. But with the water gone, this was a massive, flat-topped mesa, what geologists call a guyot, towering 3,200 to 4,000 meters above the dry ocean floor.
That's practically the height of Mount Fuji, a massive plateau just erupting out of these barren salt plains. But why does the text specifically call its peaks golden? Was there actual gold there?
This is where deep-sea oceanography perfectly validates the text. The Tropic Seamount is world-renowned today because it is uniquely covered in incredibly thick ferromanganese crusts, as well as dense layers of phosphate and carbonate.
How does a crust of metal form on a seamount?
Over tens of millions of years, metals dissolved in the seawater chemically precipitate and bind to the exposed rock of the seamount.
Like rust again?
Similar concept. It builds up millimeter by millimeter, creating a thick metallic shell.
And so when the water drops...
When the seamount was exposed to the open air as the sea levels dropped, these mineral-rich metallic crusts would catch the harsh sunlight filtering down into the basin. The ferromanganese would gleam with a distinct, brilliant, metallic golden aura.
It's literally a towering golden mountain in the middle of a fathomless dry ocean. Unbelievable.
It's a perfect visual match.
And the journey only gets more intense from there. After the Golden Boar, the army reaches Megagiri, which directly translates to the Mountain of Clouds.
Yes, Megagiri.
The Ramayan says it features 10,000 waterfalls, the constant deafening roar of animals, and it was the sacred site of the thunder god Indra's coronation.
Continuing west from the Tropic Seamount, stepping deeper into the absolute middle of that Atlantic basin, you find the Cape Verde Abyssal Rise and the Senegal Seamounts.
Let's set the atmospheric scene for this. You are walking through the deepest, hottest valley on Earth. If you look straight up, you're staring through a 5,000-meter column of dense air.
Right.
And you were standing exactly on the equator, right beneath where the most violent weather systems of the Atlantic, the Intertropical Convergence Zone, or ITCZ, are being born.
The meteorological dynamics at the bottom of a 5,000-meter deep ocean basin would be catastrophic.
I can't even imagine.
The heat radiating off the deep mantle rocks, combined with the dense atmospheric pressure, would cause massive condensation. You would have relentless, highly energetic tropical waves and perpetual deafening thunderstorms echoing off the canyon walls.
So it's constantly storming.
It is the most chemically and atmospherically violent place on the planet. It is the absolute perfect metaphorical and physical location for Indra's coronation, who is the Vedic god of lightning, rain, and storms.
But what about the 10,000 waterfalls? If the ocean is largely gone, where is the water coming from?
Even with the global sea level dropped by 5,000 meters, the basin wouldn't be completely devoid of water. There would still be massive, deep submarine internal waves and residual density currents flowing through the absolute deepest trenches and fracture zones.
Like rivers at the bottom of the ocean.
Exactly. And as these massive, fast-moving currents interacted with the steep, jagged slopes and deep canyons of the Cape Verde Rise, the water would be forced upward and then cascade down the rocky faces.
Wow.
To an army navigating the valley floor, surrounded by perpetual thunder and dark clouds, it would look exactly like thousands upon thousands of immense waterfalls pouring down the sides of the mountains.
The sensory overload of that environment, I mean, the heat, the pressure, the deafening sound of water and thunder, it sounds completely terrifying.
A literal underworld.
And they are barely halfway across the Atlantic basin. They still have to climb out.
Yes, the biggest climb is yet to come.
The army pushes through the storms, crossing the absolute deepest part of the Atlantic Trench, and they approach what is arguably the most massive geological feature on the planet.
According to the Ramayana, after surviving Megagiri, the army encounters an endless wall of 60,000 golden mountains. And positioned in the very center of this impossible range is the king of mountains, Mount Meru, radiating a blinding light.
60,000 mountains.
Yeah.
When you hear a number like that in an ancient text, your immediate instinct is to write it off as poetic exaggeration.
Sure.
Sounds like they just pick a giant number to sound impressive. Until, of course, you look at a topological map of the ocean floor.
Exactly. They aren't exaggerating, they're counting. What they are describing is the mid-Atlantic ridge.
Okay, lay it out for us.
At this specific 23-degree north latitude section, the mid-Atlantic ridge is a staggering 100 to 150-kilometer wide wall of jagged tectonic mountains stretching endlessly to the north and south.
Pick a wall of rock.
It is the longest continuous mountain range on Earth. It completely dwarfs the Andes or the Himalayas.
And with the water gone.
With the 5,000 meters of water removed, these peaks would rise 2,500 to 3,000 meters high above the basin floor. And running right down the middle of this range is a massive 1,500-meter deep central rift valley where the tectonic plates are literally pulling apart.
That's terrifying.
Standing at the base, it would look like an infinite, impenetrable wall of jagged peaks stretching to the horizon in both directions, easily tens of thousands of them.
What about Mount Meru? The text says there's a supreme central peak, the king of mountains, that anchors the entire range.
Right at 23 degrees, 36 minutes north, 45 degrees, 25 minutes west, sits a massive oceanic core complex known as the Kane Axial High.
Does it stand out from the rest?
Oh, definitely. This structure sits exactly at the tectonic intersection of the rift axis and the Kane fracture zone. Due to the unique geological uplift at this intersection, it is the supreme, dominating central peak of this entire section of the ridge. It towers ominously over the surrounding mountains and the deep rift valley.
But the text insists these 60,000 mountains are golden, and that Meru itself actively radiates light. We already talked about the ferromanganese crusts on the seamount earlier, but how can an entire tectonic mountain range spanning thousands of miles be golden?
This is perhaps one of the most stunning, scientifically precise correlations in the entire text.
Okay, I'm ready.
Located just near the Kane Axial High is the famous Snake Pit hydrothermal field.
Hydrothermal vents.
Yes. This is a highly active zone of intense, deep-sea hydrothermal vents, what we colloquially call black smokers and white smokers.
Right.
These vents are essentially fissures in the planet's crust where seawater seeps down, gets superheated by the magma below, and shoots back out into the ocean.
I've always thought of hydrothermal vents like a geological 3D printer.
That's a good way to put it.
They're constantly extruding this superheated, mineral-rich metallic ink from the Earth's mantle, and the second it hits the cold ocean water, it freezes, building these massive, alien-looking towers inch by inch.
That is exactly how they work. The superheated water is loaded with dissolved polymetallic sulfides from the Earth's interior. We're talking massive amounts of copper, zinc, gold, and most importantly, pyrite.
Fool's gold.
Exactly, pyrite, which is commonly known as fool's gold.
So they are literally painting the mountains gold from the inside out.
Yes. Over millennia, this continuous venting creates massive, towering, golden metallic sulfide chimneys. Some of these structures can reach the height of a multi-story building.
Wow.
The venting also coats the bases, slopes, and surrounding rocks in thick, glittering metallic crusts.
So it's everywhere.
The entire Central Ridge system, highly active with tectonic and volcanic energy, would be completely encrusted in gold-colored and metallic sulfide deposits.
That's incredible.
To an observer standing in that dark valley, the King of Mountains and the 60,000 surrounding peaks would literally be glittering. They would be radiating a golden metallic light as they reflected any ambient light or the glow of the underlying magma fissures.
That genuinely gives me chills. The level of detail is so granular, so scientifically accurate to a landscape no human eyes has supposedly ever seen.
It's hard to dispute the physical evidence.
So the army traverses the Rift Valley, they cross the mid-Atlantic ridge, they pass the glittering spires of Mount Meru, and they are finally nearing the western edge of the Atlantic basin.
Nearing the end.
The text says that between Meru and their final destination, there is one last massive landmark. It describes a giant golden palm tree featuring exactly 10 branches, resting on a spectacular, strange altar. The text calls it the Taladvaja.
Right. And when you cross the Atlantic from the mid-Atlantic ridge at that specific 23-degree north latitude, the first major landmass you hit as you rise out of the basin is the Bahamas and the Caribbean.
Go ahead.
Specifically, you arrive at the Bahama Banks and the Caicos Ridge.
I'm trying to visualize this, but how on earth does a geological landmass look like a palm tree? Like a literal tree with branches?
You have to look at the underlying geology of the Bahama platform when the sea level is drastically reduced and it's completely exposed above water.
Okay, paint me a picture.
The Bahamas isn't a traditional rock formation. It is a massive limestone carbonate platform. When the sea level was 5,000 meters lower, the central trunk of this massive platform rose incredibly steeply, almost vertically, from the deep ocean floor.
Like a tree trunk.
Exactly. But when you get to the top of this steep trunk, the platform doesn't remain a solid block. It fragments. It spreads out into exactly 10 distinct, long, finger-like ridges or branches separated by deep underwater canyons.
10 branches, exactly as the Sanskrit text describes.
Yes, exactly 10.
That is just...
Wow. But it gets better. Why is it a golden palm tree, and what is the golden altar it rests on?
Right, because limestone isn't golden.
No, it's not. But the entire shallow top of this massive carbonate platform is famous for being covered in brilliant, golden-white, oolitic aragonite sand.
I have to pause you there. What is oolitic sand? How is it different from normal beach sand?
Normal beach sand is usually pulverized quartz or just eroded rocks. Oolitic sand is actually chemically precipitated calcium carbonate.
Oh.
It forms in shallow, warm, highly agitated tropical waters. The calcium layers around a tiny nucleus, like a shell fragment, creating perfectly spherical, smooth grains that are incredibly bright.
So from an elevated vantage point.
From an elevated vantage point, or approaching from a distance, this massive, steep, central limestone pillar branching out into 10 distinct ridges, entirely covered in blindingly bright, golden white oolitic sand.
It perfectly matches the visual.
Perfectly matches the visual of a giant golden palm tree resting on a spectacular glowing altar. It serves as a massive, unmistakable geographical landmark just before hitting the mainland of the Americas.
Which brings us to the final stop of the journey, Ezetal, the Sunset Mountain.
The end of the line.
The Ramayana says this is the absolute end of the earth, the place where the sun finally sets, located 10,000 yoganas away from their starting point.
Continuing straight west from the Bahamian platform, crossing the Gulf of Mexico along our unwavering 23-degree north line, you cross the landmass of Mexico and hit the massive Sierra Madre and the Rocky Mountain systems on the western coast of North America.
Right.
At roughly 23 degrees north, 106 degrees west, you reach the towering coastal mountain ranges bordering the Pacific Ocean.
And if you are an ancient explorer standing on those peaks, looking west over the vast expanse of the Pacific Ocean, there is no more land.
Just water.
You have reached the optical horizon of the continent. It is literally where the sun sets on that continuous massive landmass.
Exactly. It represents the absolute western limit of that continental journey. The ocean beyond it was too deep, too vast to traverse on foot. Ezetal was the end of the road.
I took some time to calculate the math on this before we started recording, and I really need everyone listening to fully appreciate the epic, almost unfathomable scale of what we just discussed.
The sheer distance is mind-bending.
On a modern Earth, with our current diameter, traveling from central India to the west coast of Mexico is about an 18,500-kilometer trip. It's a massive journey.
Even on an airplane.
Right. But remember the premise we established at the beginning. They were navigating an expanded Earth with a 20,800-kilometer diameter.
A much larger globe.
Because the planet was so much larger, the crust was stretched out. This westward journey wasn't 18,500 kilometers. It was a staggering 30,220-kilometer journey.
It's hard to even conceptualize walking that far.
They marched over 30,000 kilometers on foot. They crossed dry, crushing ocean trenches, scaled abyssal mountains taller than the Alps, circumvented inland seas, and bypassed hydrothermal vents.
The physical scale of the journey is almost incomprehensible to the modern mind. And it brings us to a deeply critical question, really the crux of this entire deep dive.
Which is?
We have mapped this impossible 30,000-kilometer journey across vanished oceans and sunken mountains. We have matched specific rock formations, blue iron mountains, golden hydrothermal vents, and ancient riverbeds to the text of a poem.
The correlation is too perfect to be coincidental.
Exactly. Which begs the question, how? How could an ancient author or an oral storyteller possibly know this?
Right, because the beautiful thing about the source material is that in the text itself, the hero, Rama, is just as astounded as we are.
He asks the very same question.
Yeah, in Sarga 46 of the Kishkindha, after Sugriva finishes giving these incredibly detailed continent-spanning orders to his army, Rama looks at him, bewildered, and asks, "How do you know the geography of the entire Earth so perfectly?"
And Sugriva's answer is profound because it completely grounds this epic cosmic geography in a deeply personal, brutal, and relatable reality.
What does he say?
He tells Rama that he didn't learn this geography from studying a map in a library or from consulting scholarly academic texts. He learned the exact layout of the planet out of pure, unadulterated terror.
He was running for his life.
Yes. Sugriva explains that his older brother, the terrifying and immensely powerful King Bali, had violently usurped his throne and was actively, relentlessly hunting him down to kill him.
Oh, wow.
Sugriva explains that he fled across the entire globe, crossing every single river, every towering mountain range, every vanished continent and ocean basin we just described in a desperate, frantic bid for survival.
He was a refugee?
He kept running, constantly looking over his shoulder until he finally found sanctuary at Rishamuka Mountain, which was the one single place on Earth where a magical curse prevented Bali from entering.
It's the ultimate trauma-induced photographic memory. He knows every single hiding spot on the planet.
Exactly.
He remembers the Blue Iron Mountain, the inland sea, the towering gold and underwater peaks, and the terrifying weather of the abyssal plains, because his actual life depended on navigating them. He didn't casually survey the land as a cartographer. He cowered in it as a refugee.
It takes this massive, almost unbelievable geographical and geological epic and grounds it in a deeply human, deeply relatable story of sibling rivalry and raw survival.
It profoundly changes how we read and interact with the text. It's not a dry geographical treatise meant to teach a classroom. It is the frantic, hyper-detailed recollection of a political refugee who was hunted like an animal across the face of a primordial planet.
Yes, exactly.
But even if you memorize it perfectly, how does a story from 1.2 million years ago survive to be written down in the Valmiki Ramayana? Are we really supposed to believe an oral tradition lasted that long without turning into a massive game of telephone where the details get worked?
That is the genius of the ancient Indian oral traditions, specifically the concept of shruti, that which is heard.
How does it work?
These texts weren't just casually told around a campfire. They were encoded into incredibly strict, complex mathematical meters and poetic structures. The syllables, the intonations, the exact phrasing were memorized using intricate mnemonic systems designed specifically to prevent corruption over deep time.
Oh, so it's locked in.
When you lock geographical data into a rigid mathematical poem, the data survives intact even if the physical world around the storyteller changes, even if the oceans rise and the continents shift.
That is brilliant.
The story of Sugriva's flight was preserved perfectly, waiting for modern geology to finally catch up and prove it right.
Okay, let's bring this all together. We started this deep dive with a map of a 1.2 million-year-old expanded Earth, and we traced a jaw-dropping, scientifically precise alignment straight along the 23-degree north latitude line.
Every step of the way.
From the ancient shifted mouth of the Proto-Indus River at the Maghreb coast, dodging winged apex predators, across the vanished trans-Saharan inland sea, past the towering island of Hagar, logically detouring south to hit the perfectly circular eye of the Sahara and the solid blue iron of Vizra Mountain.
Down into the crushing 5,000-meter-deep dry basin of the Atlantic Ocean, past the golden-crusted tropic seamount, suffering through the atmospheric chaos and internal wave waterfalls of Megajiri.
Climbing over the 60,000 hydrothermal peaks of the mid-Atlantic ridge, shining with fool's gold, navigating the massive limestone palm tree of the Bahamas, all the way to the Sunset Mountains of the Mexican coast.
A 30,220-kilometer journey perfectly aligned with the geological, paleontological, and meteorological reality of a world that hasn't existed for over 1 million years.
If we accept that, and the geological correlations make it incredibly hard not to privy pal, what does this all mean? Why should the person listening to this right now care about the escape route of an ancient king on a planet that doesn't exist anymore?
Because it forcefully challenges us to reflect on the very nature of human knowledge, history, and memory. We're constantly taught that human history is a very short, very linear progression, that our ancient ancestors were primitive, and we are the pinnacle of knowledge.
Right, that we know best.
But if humanity's collective memory, encoded in what we casually dismiss as myth, is actually far older and far more scientifically accurate than modern textbooks allow, it changes everything.
It really does.
When a poem perfectly describes a banded iron formation, a mid-Atlantic hydrothermal vent field, and an expanding Earth model that modern science only conceptualized in the last century, we have to deeply rethink our arrogant assumptions about the past.
It means the ancients weren't just making up bedtime stories to explain thunderstorms or earthquakes. They were meticulously preserving massive data sets.
Data that we are just now uncovering.
And taking all of that into consideration, it leaves me with one final incredibly provocative thought for you to mull over as we wrap this up.
What's that?
We just spent this entire deep dive looking at the westward journey. We only tracked the single army that Sugriva sent to the west.
Right.
But Sugriva sent 4 armies. He dispatched his troops to the north, to the south, to the east, and to the west.
He covered the whole globe.
If the westward journey to the Ramayana flawlessly maps the lost geological features, the dry ocean ridges and the sunken islands of a 1.2 million-year-old expanded Earth, what vanished continents, what sunken civilizations, or terrifying predators are perfectly described in the other 3 directions?
That is a staggering thought.
What other massive geological ghosts are hiding in plain sight in our oldest stories, just waiting for us to unfold the right map?